the manic reaction. Let me bring it down a little bit. All right, I have three things, well, four things. I need the acid. I have four things. I have formaldehyde, I have a ketone, and I have an amine. I also need acidic conditions for this reaction. So what's going to happen, I'm going to do it in colors. I need another color. Let's make it blue. What's going to happen is that I'm going to alkylate the alpha carbon of my ketone. So there's my ketone. I'm going to use the methylene from the formaldehyde, and I am going to attach the amine to the methylene of the formaldehyde. This right here is a salt of the manic base. And it's actually stable, and you can just save it until you're ready to use it. When you're ready to use it, I have a chloride cation, so what I have is the hydrochloride salt. When you're ready to use it, you need to neutralize your hydrochloride, so a little bit of sodium hydroxide, little by little, a solution of sodium hydroxide. That will get you your free base, so I'm deprotonating the nitrogen. And this is your free base. Now every time I have seen this reaction, they use formaldehyde, and I need a big difference between the reactivity of the carbonyl of formaldehyde and the carbonyl of the ketone. They have to be very, very different in how partial positive that carbonyl is. So I'm going to go through the mechanism of this reaction, and you'll see why. The first step is the formation of the iminium ion, and what happens is that the most reactive carbonyl is the formaldehyde carbonyl, and the nitrogen, your amine, is going to attack it, and it's going to form an iminium salt. Now notice that I have formaldehyde. Normally when you use a secondary amine, you would make an N-amine, but I don't have a choice. I don't have an alpha carbon here. So the double bond has to stay in place, and the nitrogen is going to have to be positive. And that's why this is referred to as the salt, because it's an iminium salt. So this is what's happening with the formaldehyde. What's happening with the ketone is that it's forming an enol. Under acidic conditions, and by the way, this should be a positive, so make sure you fix it in your notes. Under acidic conditions, the oxygen will get protonated, and of course you cannot, well, let me get it protonated, and then we'll just do it. Because the double bond, you're going to form an enol, and you and I know that an enol has a carbon-carbon double bond. It's not stable, so in terms of the equilibrium, this equilibrium would shift more to the other side. So let's just exaggerate it. It's going to go backwards, really big. But this right here, what's important on this is that the carbon, the alpha carbon of the enol, it's nucleophilic. So this carbon is nucleophilic, this carbon is electrophilic, and negative attacks positive, so get those two together. You ready to get them together? Reform carbonyl and make this double bond attack the carbon of the formaldehyde, of the iminium. And we're almost done. Alright, so we did form the carbonyl back. We attacked the CH2. And we have two methyls attached to your nitrogen. But I have a protonated carbonyl and I have a base on the other side. So what's going to happen? The base is going to deprotonate your carbonyl. And that's how you get the salt of the manic base. It's going to be a chloride salt. All right, let's do a problem. Well, let's do two problems. So I have cyclopentanone. We're going to add formaldehyde. And we're going to add ammonia. We need a little bit of HCl. So when you do this reaction, remember that the alpha carbon of the ketone is going to end up attached to the CH2 of the formaldehyde, which is going to end up attached to the nitrogen. All right, here we go. I'm going to do it in color. So your cyclopentanone doesn't change. We just alkylated the alpha carbon, and we have an amine attached to it. So you can deprotonate or you can leave the 3 hydrogens in there and you get the salt. And the counterion would be the chloride. Do the reaction again just as another practice. Cyclohexanone, formaldehyde, because we always use formaldehyde. And this time around we're going to use cyclohexamine. So we're going to mix those 3. Take your ketone and redraw it. Attached a CH2 to it from the formaldehyde. And attached your nitrogen to it with whatever it is it has attached to it. This one has the cyclohexyl attached to it. It's positive, so my counterion is going to be the chloride of, ooh, I forgot to put the HCl. The chloride of the HCl. All right, that's part 3. Make sure you listen to part 4. So this is the manic reaction.